Three randomly selected households are surveyed. The numbers of people in the households are 2, 6, and 7. Assume the samples of size n equals 2 are randomly selected with replacement from the population of 2, 6, and 7. Construct a probability distribution table that describes the sampling distribution of the proportion of odd numbers when samples of sizes n equals 2 are randomly selected. Does the mean of the sample proportions equal the proportion of odd numbers in the population? Do the sample proportions target the value of the population proportions? Does the sample proportion make a good estimator of the population proportion? Listed below are the 9 possible samples. So we can see that what we have here are 9 samples. We have where 2 was selected with 2, 2 was selected with 6, 2 was selected with 7, and then 6 was selected with 2, 6 was selected with 6, and 6 was selected with 7, and then 7 was selected with 2, 7 was selected with 6, and 7 was selected with 7. And it's important to note that it said that these selections were made with replacement. So each one of these represents a different selection. So the key things here are to construct a probability distribution table that describes the sampling distribution of the proportion of odd numbers. So we need to look at each of these samples and decide, well, in each one of these samples, what proportion of the numbers are odd. In the first one, 0 out of 2 are odd. In the second one, 0 out of 2 values are odd. In the third one, 1 out of 2 values are odd. And then we have 0 out of 2, 0 out of 2, and on down here. Actually, in this one here that's 7 and 7, we have 2 out of 2, so 100%. But what we found is that we either have 0%, or from a proportion standpoint, 0 out of 9, and that happens with the 2 and the 2, the 2 and the 6, the 6 and the 2, the 6 and the 6, and that's it. So we have 1, 2, 3, 4 out of 9. Then we have some where half of the values in the sample are odd, like with this 2 and 7. There are 2 values there, a 2 and a 7. The 7 is odd out of 2 values, so that's half. So 50% of the values in that sample are odd. So let's see, that happens with the 2 and the 7, the 6 and the 7, the 7, the 2, and the 7, and the 6. So that's 4 out of 9. And then we have a case where both of the values in the sample are odd. That's with the 7 and the 7. So that's 100%, or from a proportion standpoint, 1, a proportion of 1, and that happens 1 out of 9 times. Now to continue through the problem, the next question is to choose the correct answer below. The proportion of odd numbers in the population is equal to the mean of the sample proportions. Okay, well, in order to find the mean of the sample proportions, we're going to have to multiply each of the values in the probability distribution by their respective probabilities and then add all that up. So the formula is the sum of the values of the random variable multiplied by their respective probabilities. So first one we have is 0 times 4/9 plus 0.5 times 4/9 plus 1 times 1/9. Okay, so let's see. Well, this first term is going to be 0. The second one's going to be 2/9. The third one is going to be 1/9, which is going to give us 3/9, or in other words, 1/3. Now, that is the mean of the sample proportions. Remember that the mean for a probability distribution is just the sum of the products of the values of the random variable. These are our values, and these are our probabilities, times the probabilities. Okay, so the question then is, does this value, this mean, represent the proportion of odd numbers in the population? Well, yes, the odd numbers in that particular population are represented only by the value 7. The population consists of 3 values, 2, 6, and 7. So that mean then is, or that proportion rather, is 1/3. 1/3 of these values, 1 out of 3, are odd. So we want to look through here and find the response that says that the proportion of odd numbers in the population is equal to the mean of the sample proportions, which will be A. And continuing through the problem, we're supposed to choose the correct answer. The sample proportions target the proportion of odd numbers in the population, so sample proportions make good estimators of the population proportion. So just reading the first one, we can see what they're after here. They're saying, does the mean of the sample proportions make a good estimate for the proportion of odd numbers in the population? And that would be the case if those two values were equal in the way that we just found. So let's see, the first response says the sample proportions target the proportion of odd numbers in the population, so sample proportions make good estimators of the population proportion. And that is the case, so we'll select that, check our answer.